So now that we know what a linear function is, we have to be able to construct one so we can model data. And this is part one of a two-part series in this idea of constructing a linear function. So just for review, the parts of a linear function are your slope and your y-intercept. And when we construct a linear function, we are writing a linear equation in slope-intercept form. And slope-intercept form is the equation y equals mx plus b, where m is the slope and b is the y-intercept. Hence the name slope-intercept form, because we have slope and the intercept. So how do we construct a linear function from a table? Well, to construct a linear function from a table, we have to find the slope and the y-intercept, and then substitute those into the equation y equals mx plus b. And to find the slope, we do the following. We find the values for the change in y and the change in x, and we substitute those values into the formula m, or slope, is equal to the change in y over the change in x, which is equal to delta y over delta x, where delta, the little triangle, is the Greek letter for change. To find the y-intercept, we can do the following. We can find when x is 0 in the table, or we can use the slope to help us work backwards to when x is equal to 0. So constructing a linear function from a table example. So we have the weight of gummy bears in ounces and the price in dollars. So our slope, we know the change in y is 25 cents because we're adding 25 cents each time. And the change in x is 1 ounce because we're adding 1 ounce each time. So our slope is going to be delta y over delta x, or the change in y over the change in x, and the change in y is 25 cents, and the change in x is 1 ounce, and 25 cents divided by 1 ounce is equal to 0.25, because 0.25 divided by 1 is 0.25. So our slope is 0.25. So m is equal to 0.25. Our y-intercept is when x changes by 1 ounce, y changes by 25 cents. So to get when the weight is 0, so when we get x is 0, we subtract 1 ounce. And when we subtract 1 ounce, we also subtract 25 cents from the price. Why? Because x is changing by 1, y is always going to change by 25. So when the weight is 0, the price is also going to be 0, so our y-intercept is 0. So b is going to equal 0, and our equation is going to be y equals 0.25x plus 0, which is also equal to 0.25x. So how do we construct a linear function from a graph? Like for a table, we need to find the slope and y-intercept, so we can substitute those values in slope-intercept form. And to find the slope, we're going to do the following. We're first going to find the vertical change in the graph, or the rise, and then we're going to find the horizontal change of the graph, or the run. And we substitute those values into the formula m equals the vertical change of the horizontal change, which equals the rise over the run. Most of you are going to memorize it as rise over run, which is totally fine. To find the y-intercept, we find the value of y when the y crosses the y-axis. So constructing a linear function from a graph example. So in this one, the green line here represents the vertical change, or the rise, and the orange line represents the horizontal change, or the run. The vertical change goes down 1, 2, 3, 4. So the value of the rise is -4 because we're going down 4. The horizontal change goes to the right, 1, 2, 3, 4, 5. So the value of the run is 5 because when we go to the right it's positive. So m equals rise over run, which is in this one, since the rise is -4 and the run is 5, our slope is going to be -4 over 5. And the y-intercept, the graph crosses the y-intercept, the y-axis, at 4, so b is going to equal 4. So our linear function is going to equal y equals -4 fifths x plus 4. And that is the end for today.